Hi, my name is Taiwo Ikelua. I'm an undergraduate student of informatics and computer engineering at VNU IS. So today I'm going to be walking you through my class project, which is detecting spam email using logistic regression. So first I'm going to talk about the invention of logistic regression briefly, and then I'm going to move to why do we need logistic regression. So, so logistic regression, I'm going to talk about the invention and the importance in classification. Logistic regression is one of the earliest and the most influential statistical techniques used for binary classification. So in 1944, American statistician Joseph Bergson formally introduced logistic regression as a model for predicting categorical outcomes. Logistic regression is valued for its simplicity, efficiency, and interpretability, ensuring it remains a corner technique in both academic research and real-world machine learning applications. Its origin dates back to 19th century when Belgian mathematician Pierre Francois Fahort introduced the logistic function. The importance of logistic regression stems from its ability to model the probability of an outcome belonging to a specific class, particularly in binary settings, e.g., yes or no. So, why do we need logistic regression? Logistic regression is particularly useful for predicting binary outcomes, such as whether a message is spam or not. The target variable is spam or ham, which is binary, and it performs well with high-dimensional data, such as text transformed into TF, IDF vectors. And then number two, this function is fast to train and test, making it suitable for real-time or large-scale applications. So next, I'm going to talk about methodology, the methodology of this project. And the first thing I did was collect data, the data collection. And the data set used in this project is the email spam collection, which is a public data set available as spam CSV. So this data set contains labeled email messages categorized into two classes, which is ham and spam. Ham is the legitimate or non-spam messages, and spam is the unwanted or malicious messages. And the second is the data pre-processing. So, data pre-processing ensures that the data is clean and suitable for machine learning algorithms. And the second thing is the column selection and renaming. Only two relevant columns, VI and V2, were selected and renamed to label and text for clarity. And the next thing is the label encoding. The labels were converted into binary values. And ham is converted to 0 and spam is converted to 1. And the first thing is handling the missing or empty data set. So rows with missing or empty text values were removed to ensure data quality. So I'm going to talk about the text vectorization using TF and IDF. A TF-IDF vectorizer was used to convert the text into a matrix of weighted word frequencies, and the configuration is as follows. And the next thing is the model selection and training. The logistic regression classifier was chosen for its simplicity and effectiveness, and here is the hyperparameters used. So after this, we'll train and test the data set. The data set was split into training and testing set. The training set is about 80% of the data, and the test set is just 20%. So next is next is the model evaluation. The model was evaluated using standard classification matrix, and then the accuracy score measures the overall correctness of predictions. The classification report includes precision, recall, and F1 score. So the model saving and deployment. First thing, the model was saved for future use after everything in the local environment, and we save the model, and also we load the model on VS4 for interactive sets testing. So a simple Python script was created for user to input custom emails and receive real-time prediction from the model, which is like the live demo. So the result, the class distribution and support. The dataset includes 965 ARM messages and 150 spam messages. The classification report confirms significant differences between the two classes. The class harm, which is 0, the precision was 0.96 and the recall was 0.99 and F1 score was 0.97. And the class spam performance, which is 1, the precision is 0.91 and the recall is 0.71 and F1 score is 0.80. The macro and weighted averages, the precision 0.94, recall 0.85, F1 score 0.89. So the next thing I'm going to talk about is the conclusion and the future directions. So this project successfully demonstrated the development of an effective email spam detection system using logistic regression. The model achieved a high test accuracy of 95.25%, and future improvement could include improving spam recall, advanced test preprocessing, exploring alternative models, adding extra features, building a user interface, and deploying in real-time systems. So here is the source code. Just like I said, we import all the functions needed, and so from Google Colab we import the file, which is email spam CSF, and then we import data and load the data set, and we display the first few rows, and after this we drop the unnecessary columns and we kept only the V1 and V2. And then we rename the columns to be label and text and display the updated data frame. After this, we check for missing values and check for empty strings. And we remove the missing row or empty values. And after that, we label to binary, which is ham0 spam 1, and we verified the mapping. So after this, we'll train the data set, we test the data set and split. And with this function, which is TFID vectorizer, we convert to matrix and create a pipeline. And after all this, we make the prediction and calculate the accuracy and all. And after that, we save the pipeline and we downloaded the file into the local environment. So now this is the live demo. So now this will prompt the user to just input anything. So we want to check if this message is spam or not. So I'm just gonna enter a message. So this is the prediction. Predicted that this message is not spam, and the spam probability is quite low, very low, which is 2.0.2%, and the not spam probability is very high, which means that this message is not spam. So we are going to test for a real-time spam message now. So the prediction is that this message is a spam message, and the spam probability is very, very high, which is 99.36%. And that this message is not spam, the probability is very low, which is 0.64. So I've come to the end of my presentation, and thank you very much for listening.